Welcome to UGC lecture series Linear Integrated Circuits. This lecture deals with the clipper, the positive and negative clipper, peak clamper, peak detector and sample and hold circuit. Clipper. The wave shaping circuits are commonly used in digital computers and communication such as TV and FM receiver. This includes the clipping and clamping. In op-amp clipper circuits, a rectifier diode may be used to clip off a certain portion of the input signal to obtain a desired output waveform. In a positive clipper, if the input signal is greater than the V reference is given as one of the input signal and the AC signal which is given as another input signal. If the input signal is greater than V reference signal, then the portion which is greater will be clipped off in the output signal, which is in the positive clipper. The signal which is above the V reference is clipped off in the positive clipper, and there is another clipper called a negative clipper where the signal which is lower than the V reference signal will be clipped off. So, this is the circuit for a positive clipper. Signal is given to the positive terminal. This alternating signal is given to the positive terminal, and reference voltage which is taken from the positive supply to the operational amplifier through the resistance Rk, which is given as the another input of the operational amplifier. So, here the V reference is given to the negative terminal of the operational amplifier, and this entire setup is used with the precision diode. So, the output of the operational amplifier is having a diode, and which is at the other terminal the output is fed back to the input terminal of the operational amplifier. So, the output of the op-amp has a diode which is the setup of the precision diode, and which is denoted as D1 now. So, when you look at the input and output waveforms, if the reference voltage is set as positive, the input voltage above the reference voltage, this portion will be clipped off for the positive clipper. When you see a reference voltage is negative, again the input voltage is above the reference voltage, then those portions are clipped away in the output. So, this is for the positive clipper. Whatever the reference voltage is given, either it is a positive reference or a negative reference, the input signal above the reference voltage will be clipped away at the output. This is for the positive clipper. So, now we will look at the circuit, how it is going to be worked. If V reference is set as 2 volt and V in is actually varying between plus 3 volt to minus 3 volt. So, which is having a values for the positive direction it is 1 and 2 and 3, and for the negative direction it is 0, minus 1, minus 2 and minus 3. So, these are the values of the alternating input signals at instant of time. So, how will you get the output for this particular circuit? Now, if the input signal is positive, the input signal is given to the positive terminal, and so you have to get the net result of the voltages at these two terminals. So, we will calculate if Vin is equal to 0 and V reference is equal to 2 volts, the output will be equal to, V out will be equal to V in minus V reference, because this minus indicates that V reference is given to the negative input terminal of the operational amplifier. If 0 is the input voltage and 2 is set as V reference, then the output voltage will be minus 2 volts. Similarly, if you increase the input voltage as 1, 2, 3, that is the peak of the input voltage in the positive direction. So, you will be getting the reference voltage is always equal to 2 volts, and this minus sign indicates that the reference voltage is given to the negative input terminal of the operational amplifier. So, the net output of this particular operational amplifier now is, this is minus 1 volt and here it is 0 volt and here it is 1 volt. So, this is for the positive input. And what happens if the input is negative? So, here minus 1 is given, so you will be getting the output minus 3, and if it is minus 2, what happens if it is minus 3? So, the maximum voltage at the negative side is minus 3 and maximum Vm, that is the peak voltage at the positive direction, is 3. So, I have calculated up to 3 in the positive direction, up to minus 3 in the negative direction. So, it is equal to minus 4 volts and here it is equal to minus 5 volts. So, these are the output voltages for a positive and negative half of the input signal with the peak voltage 3 to minus 3 volts. So, you can draw the circuit like this is 0 and we know that the reference voltage is minus 2. Consider here as reference minus 2, sorry, plus 2, and which is given to the negative terminal. So, here 1, 2, 3, 4 and here minus 1, minus 2, minus 3, minus 4. Okay. So, here if the input voltage is 0, then the output voltage is minus 2 volts. If the input is 1 and the output is minus 1, if the input voltage is actually if the output of the operational amplifier V dash, this is actually V dash, not at the output, these are all V dash. So, if it is minus 2 volt, this diode will conduct, and if the output of the operational amplifier is negative, then the diode will conduct, and if the output if the diode is conducting, then you will have a feedback from the output to the input direction. If the diode is in off position, then there is no output at the output terminal of the circuit. So, here if the reference voltage is 2, then up to 2 it will be conducting, because you have a negative voltage at this point, then the negative voltage is given to the negative terminal of the diode. So, the diode will conduct, then the voltage will follows, the output will follow the input voltage up to 2 here. So, you can draw this up to 2, the diode will conduct, and after 2, when you see 3 volt, when you take 3 volt, then it is 1 volt, positive 1 volt. So, if you give a positive voltage to the negative terminal of the diode will be in off position. So, there is an open circuit. So, there is no output here. The reference voltage will be the output here, since it is given to the connected to the output terminal. So, what is the reference voltage? It is 2. The reference voltage is 2, and again when the input voltage is minus 1, you have a minus 3 volts at the output of the operational amplifier. So, whenever you have a negative voltage at the output of the operational amplifier, the diode will conduct, and if it is conducting, then the output follows the input signal, since these two input voltages are virtually equal. So, for the negative for the V dash negative, the diode conducts, so it will follow the input voltage for the remaining values of the inputs. So, in this way the positive clipper will work. If you see these two diagrams, the input and the output, so this is the output. After the reference voltage 2, the input voltage will be clipped off. Below the reference voltage, whatever the input voltage is present, it will be taken across the output terminal of the circuit. So, this is the positive clipper, and you can also set the V reference as negative voltage by having a resistor connected to the negative supply voltage given to the positive terminal. So, if you change this plus VCC as minus VEE and the remaining keep the remaining setup as such, then you are giving instead of a positive voltage, you are giving a negative V reference voltage. In that case, if you take minus 2 volts here, then the voltage above the reference voltage is clipped away. Only below the reference voltage you will be getting at the output. You can consider the voltage as a minus 2 volts, and you can calculate these outputs and check whether what is the output of that particular positive clipper. Okay, how will you convert this positive clipper into a negative clipper is, you have to just you have to reverse the diode at the output of the circuit. In the previous case, the negative terminal of the diode is connected to the output of the operational amplifier. Now it is the positive terminal of the diode is connected to the output of the operational amplifier. That is the only difference between the negative and the positive clipper. In this case also, the reference voltage can be a negative voltage or a positive voltage, but at the output, if you see the waveforms, the input signal is an alternating signal, and we have set the V reference as minus 1 volt. This is the negative V reference. If it is set, then the voltage, the input voltage above the V reference is actually taken across the output, and the input voltage below the V reference is clipped away. Similarly, if the V reference voltage is positive, then above the voltage is obtained at the output. Whatever the input signal which is above the V reference is obtained at the output, and the input voltage which is lesser than the V reference is clipped away. This is for the negative clipper circuit. So, how the circuit will work for a positive and the negative V reference, we can just discuss. Input signal is given to the positive terminal, and the diode is present at the output of the operational amplifier, and V reference is given to the negative terminal of the operational amplifier. Now, this voltage you have to calculate according to the voltage present at the positive and the reference voltage present at the negative. So, first initially if you set the V reference as positive, say 1 volt, and the V in voltage is alternating in between minus 3 to plus 3. And what happens for the diode? So, if the output of the operational amplifier is positive only, then the diode will conduct. If the diode conducts, then the output follows the input. Since these two terminals are virtually equal, then the input voltage will also be seen across at this input terminal also. So, when the output of the operational amplifier is positive, then the diode will work. So, when the output is positive, if the net result is positive. If the net result is reduced, if it is negative, then the diode will not work. If it does not work, then there is an open circuit between the output of the op amp and the output of the circuit. And so, the output at that time, the output of the circuit is actually the V reference voltage. Whatever the V reference is given, then the same voltage will be taken at the output of the circuit when the diode is in off position. So, you can give some value for the reference voltage. Here it is given as plus 1 volt and minus 1 volt. In this case it is minus 1 volt. You can take the maximum of V in as plus 3 to minus 3, and you can calculate the output of the operational amplifier and check for whatever the values of the output, the diode is on and the output follows the input, and check for what values the diode is off, the output is the V reference value. You will be getting the output like this. This is the negative clipper. If the reference voltage is given, the input voltage is if it is lesser than the reference voltage, those voltage will be clipped away in the output, whatever the reference voltage may be, either it is a positive or a negative. If it is a positive value, positive reference, if you want to give a positive reference, then you have to take it from the positive supply. If you want to give a negative reference, take it from the negative supply of the operational amplifier. Clamper. What do you mean by clamper? In clamper circuit, a predetermined DC level is added to the output voltage. The output is clamped to a desired DC level. If the clamped DC level is positive, then the clamper is positive clamper, and if the DC level is negative, then it is a negative clamper. So, this circuit is actually a peak clamper, positive peak clamper. Look at the circuit. The positive terminal has the reference voltage and the negative terminal has a signal, alternating signal through the capacitor, and at the output again there is a diode D1 connected, and which is connected again to the output voltage, and where a load resistance is connected to take the output voltage across it. The feedback resistance is connected from the negative terminal of the anode to the resistance R. So, here the loop is present, and in this circuit we have to examine this circuit with 3 cases. One is only if the V reference is given, what happens to the output and what happens to the capacitor and what happens to the circuit. And if the input signal is negative, what will be the output, and if input signal is positive, what will be the output. We will be discussing now. So, case 1, if only V reference is given, and consider Vi is equal to 0. So, if Vi is equal to 0, at this point 0 volts is given and V reference is given. So, what is the output of the operational amplifier? It is V reference. If Vi is 0, then the output will be V reference. V reference minus Vi, so Vi is 0, so the output is V reference. If it is positive value, then the diode will be on. If it is on, then if it is on, and all through this diode there will be a current flowing towards this loop. But here if you consider only the V reference, the input voltage is 0 and there is a short circuit across the diode because the voltage at this terminal is positive, so it is forward biased, and you can take the output of the circuit as V reference now. Diode is on and output is taken as V reference now. If only V reference is given, the output is V reference. And for the case 2, if the input signal is negative, if Vin is negative, what happens to the circuit? If Vin is negative and V reference is given, and what is the output of the circuit? Negative input voltage. So, you have to calculate the net result at the output. We can take this as VO dash, this voltage as VO dash. The net result at the output of the operational amplifier is V reference minus Vin, because we are giving a negative voltage at the input of operational amplifier. So, you will be having V reference plus Vin at the output of this operational amplifier. So, this diode will be conducting and through the diode, and we are also giving an input, negative input to the negative terminal of the operational amplifier. So, through the diode the capacitor will charge towards the maximum peak of the input signal, and so the capacitor voltage Vc will be given as V reference plus Vm. This is the maximum voltage the capacitor can charge. And the case 2, case 3, in case 2 we have seen the input voltage as negative, and in that case the diode is on, the capacitor start charging towards the negative voltage and peak of the negative voltage. So, it is given as V reference plus Vm. So, here the net result is V reference plus Vm. So, the capacitor charging towards that voltage. And in case 3, Vin is positive. It is positive. If the voltage is positive, which is given to the negative terminal, and this output voltage is, if it is positive, then you will be getting a negative voltage here. If it is positive, you will be getting a negative voltage here, and this diode will not conduct. If the diode is not conducting, then output voltage will be the input voltage plus the capacitor voltage. What is the capacitor voltage? Previously in the case 2, it is actually V reference plus Vm. So, the output V out is equal to V reference plus Vm plus Vin. This is the voltage at the output if the input voltage is positive. So, these are the cases for which we have seen the output of the operational amplifier as well as the output of the circuit peak clamper. So, you can give some values so that you can draw the output waveform for the clamper. Take V reference as 2 volts and input voltage Vm is actually -3 to +3. Now I have taken it as the positive peak as 3, and I am going to calculate V out, the entire circuit's output. So, this is the actual equation to calculate the output of the entire circuit. So, here instead of V in, you can change the input voltage according to the positive and negative input voltage. So, you have to give from 0 to +3 and -1 to -3. So, V reference is 2 volts plus Vm is 3. This is constant always, and the input value will be changing. If it is 0, then it is 5 volt. If it is 1, it is 6. If it is 2, it is 7. If it is 3, 8. -1, 2 plus 3 minus 1. Okay, 2 plus 3 minus 1, it is 4. 5 minus 1, 4. Similarly, if it is -2, 1 is reduced from here, it is 3. It is -3, it is 2. So, for all the values 0 to 3 and -1, -2, -3, you have calculated the output of the circuit. So, now we can draw the circuit for the input voltage with the peak voltage -3 to +3. So, consider this as the input voltage, consider this as the input voltage from -3 to +3. 0, this is 3, this is -3. What is the V reference we have taken? V reference is 2 volt. So, the clamper will clamp this input signal by the value of the V reference 2. That is actually the function of the clamper. Now, you have to draw the output waveform according to the new values. So, this is the input voltage Vi. The output voltage is drawn here, going to be drawn here, and if the input voltage is 0, then the output is 5. You have to mark it as up to value 8. So, 1, 2, 3, 4, 5, 6, 8. Okay. If the value of the input signal is 0, then here it is 5. It is 5. And if the input signal is 1, it is 6. So, you have to draw like this, and if the input signal is -1, it is 4 here. If it is -2, it is 3. It is 3, and if it is -3, it is 2. So, the lowest value is 2, which is nothing but our V reference value. V reference is 2 volt. So, these are the voltages for the new output signal. So, here the by the V reference value, the input signal is clamped at the output by the V reference value 2. If the V reference is set as 3, then above 3 volts the input signal is clamped. So, according to the value of the V reference, the input signal is clamped. So, it is this peak clamper is otherwise known as DC inserter or DC restorer. So, these are the two names for the peak clamper. If the diode is reversed, then you have to you can clamp the negative peaks of the input signal. Here it is the positive peaks of the input signal is clamped. If the diode is reversed, then you can clamp the negative peaks of the input signal. So, this circuit is the peak detector circuit. So, So, in this circuit again at the output you have a diode and the output of the diode is fed back to the input of the operational amplifier. Input signal is given to the positive terminal and the output is having a capacitor which is going to hold and store the value of the peak of the input signal. So, this circuit is going to detect and store the amplitude of the peak of the input signal, positive peak of the input signal. So, whenever the input voltage is higher than the voltage across the capacitor, then the diode will conduct, and if it is conducting, then the capacitor will store the new higher peak. For example, if the voltage, consider this voltage as an input signal, if the voltage is given, if you have a positive output, then the diode will conduct. If the diode is conducting, then it follows the input voltage, and at the output it will give you the input. So, it is a voltage follower circuit if the diode is on, and the capacitor will have a highest peak of the input signal now. So, if a new peak is arriving at the input, then the capacitor will hold the new one. So, when the capacitor will calculate the value of the new peak is this voltage, the V dash out must be greater than this Vc. So, when you look at the waveform, this peak at the time t1 is missed out. This is because the capacitor voltage is already very high and the input voltage is low. So, in that case the diode will be off. So, there is no connection between the output and the input. So, the capacitor keeps the previously stored higher peak value. So, this peak is missed out. Similarly, these two peaks are missed out because these input voltage is not higher than the capacitor voltage which is stored already in the across the capacitor. And the voltage across the capacitor can be discharged by connecting a parallelly a MOSFET switch. So, this is the peak detector which can be used for detecting and storing the values of the higher peaks present at the input, positive peaks present at the input. If the diode is reversed, then you can detect the negative peaks present at the input. Can you answer for these questions? What are the wave shaping circuits, and how is a positive clipper converted into a negative clipper, and what is the function of the positive clipper? What is the sampling frequency set for the sample and hold circuit, which we will be seeing in the next session. And we have seen today the wave shaping circuits where we have seen clippers and clamper. In clipper there are two types. It is a positive clipper and a negative clipper according to the V reference value set, and the circuit diagrams, the diode, the position of the diode connected at the output of the operational amplifier. The clipper can be divided into two, the positive and the negative clipper. And peak detector we have seen. The sample and hold circuit we will be seeing in the next session. These are the references. Thank you.